The grandfather paradox is a proposed paradox of time travel which results in an inconsistency through changing the past. The paradox was described as early as 1931, and even then it was described as the age-old argument of preventing your birth by killing your grandparents. Early science fiction stories dealing with the paradox are the short story Ancestral Voices by Nathaniel Schachner, published in 1933, and the 1943 book by René Barjavel Future Times 3. The paradox is described as follows. The time traveler goes back in time and kills his grandfather before his grandfather meets his grandmother. As a result, the time traveler is never born. But, if he was never born, then he is unable to travel through time and kill his grandfather, which means the traveler would then be born after all, and so on. Despite the name of the grandfather paradox does not exclusively regard the impossibility of one's own birth. Rather, it regards any action that eliminates the cause or means of traveling back in time. The paradox's namesake example is merely the most commonly thought of when one considers the whole range of possible actions. Another example would be using scientific knowledge to invent a time machine, then going back in time and impeding a scientist's work that would eventually lead to the invention of the time machine. An equivalent paradox is known as auto-infanticide, going back in time and killing oneself as a baby, assuming the causal link between the time traveler's present and future. The grandfather paradox that disrupts that link may be regarded as impossible. However, a number of hypotheses have been postulated to avoid the paradox, such as the idea that the past is unchangeable, so the grandfather must have already survived the attempted killing, or the time traveler creates, or joins, an alternate timeline or parallel universe in which the traveler was never born. A variant of the grandfather paradox is the Hitler paradox or Hitler's murder paradox, a fairly frequent trope in science fiction, in which the protagonist travels back in time to murder Adolf Hitler before he can instigate World War II. Rather than necessarily physically preventing time travel, the action removes any reason for the travel, along with any knowledge that the reason ever existed, thus removing any point in traveling in time in the first place. Additionally, the consequences of Hitler's existence are so monumental and all-encompassing that for anyone born after the war, it is likely that their birth was influenced in some way by its effects, and thus the grandfather paradox would directly apply in some way. Scientific theories. Novikov self-consistency principle. The Novikov self-consistency principle expresses one view onto how backwards time travel could be possible without a danger of paradoxes. According to this hypothesis, physics in or near closed time-like curves can only be consistent with the universal laws of physics, and thus only self-consistent events can occur. Anything a time traveler does in the past must have been part of history all along, and the time traveler can never do anything to prevent the trip back in time from happening, since this would represent an inconsistency. Novikov et al. Used the example given by physicist Joseph Polchinski for the grandfather paradox of a billiard ball heading towards a time machine. The ball's older self emerges from the time machine and strikes its younger self, so its younger self never enters the time machine. Novikov et al. Showed how this system can be solved in a self-consistent way which avoids the grandfather paradox, though it creates a causal loop. Seth Lloyd and other researchers at MIT have proposed an expanded version of the Novikov Principle, according to which probability bends to prevent paradoxes from occurring. Outcomes would become stranger as one approaches a forbidden act, as the universe must favor improbable events to prevent impossible ones. Parallel universes. One variant of the grandfather paradox is that when the traveler kills the grandfather, the act took place in a parallel universe where the traveler's counterpart never exists as a result. However, his prior existence in the original universe is unaltered. Succinctly, this explanation states that if time travel is possible, then multiple versions of the future exist in parallel universes. This theory would also apply if a person went back in time to shoot himself, because in the past he would be dead, as in the future he would be alive and well. Examples of parallel universes postulated in physics are in quantum mechanics. The many worlds interpretation suggests that every seemingly random quantum event with a non-zero probability actually occurs in all possible ways in different worlds, so that history is constantly branching into different alternatives. The physicist David Deutsch has argued that if backwards time travel is possible, it should result in the traveler ending up in a different branch of history than the one he departed from. In 2014, researchers published a simulation validating Deutsch's model with photons. Tim Ralph, one of the authors, explained that in the closed time-like curve simulation, the state we got at our output, the second photon at the simulated exit of the CTC, was the same as that of our input, the first encoded photon at the CTC entrance. See also quantum suicide and immortality. M-theory is put forward as a hypothetical master theory that unifies the 6 superstring theories, although at present it is largely incomplete. One possible consequence of ideas drawn from M-theory is that multiple universes in the form of 3-dimensional membranes known as brownness could exist, side by side in a fourth large spatial dimension. See Branagh cosmology. However, there is currently no argument from physics that there would be one Branagh for each physically possible version of history as in the many worlds interpretation, nor is there any argument that time travel would take one to a different Branagh. Other considerations. Consideration of the grandfather paradox has led some to the idea that time travel is by its very nature paradoxical and therefore logically impossible, on the same order as round squares. For example, the philosopher Bradley Dowden made this sort of argument in the textbook Logical Reasoning, where he wrote, "Nobody has ever built a time machine that could take a person back to an earlier time. Nobody should be seriously trying to build one, either, because a good argument exists for why the machine can never be built. The argument goes like this. Suppose you did have a time machine right now, and you could step into it and travel back to some earlier time. Your actions in that time might then prevent your grandparents from ever having met one another. This would make you not born, and thus not step into the time machine. So, the claim that there could be a time machine is self-contradictory. But some philosophers and scientists believe that time travel into the past need not be logically impossible provided that there is no possibility of changing the past, as suggested, for example, by the Novikov self-consistency principle. Bradley Dowden himself revised the view above after being convinced of this in an exchange with the philosopher Norman Swartz. Consideration of the possibility of backwards time travel in a hypothetical universe described by a Gödel metric led famed logician Kurt Gödel to assert that time might itself be a sort of illusion. He seems to have been suggesting something along the lines of the block time view, in which time does not really flow, but is just another dimension, like space, with all events at all times being fixed within this 4-dimensional block.